All right, so we'll start off just to go in order here. We will start off with number one. So conical paper cup, 3 inches across the top, 4 inches deep, is full of water. So this is number one. Let me change this to a pen here. So conical paper cup. And they say that the diameter is 3 inches across the top, so that's 1.5 this way in inches, and 4 inches in height. Okay, so this is 4 inches. All right. The cup springs a leak at the bottom and loses water at a rate of 2 cubic inches per minute. So springs a leak at the bottom and loses water. Okay. So water is volume, right? So we know that because of the units. It says cubic inches per minute, right? Cubic inches, that's volume per minute. That's going to be over time. So that's going to be my volume. The dV/dt is equal to, they say it's losing water, so -2 cubic inches per minute. Okay, so there's the water. And how fast is the water level dropping at the instant when the water is exactly 3 inches deep? So water level is going to be your height, right? So they want to know what is dH/dt when the water is exactly 3 inches deep. So H equals 3 inches. Okay, that's the main question that we have. Express the answer in inches per minute. So they actually told you your units. So again, I have a cone. Okay, now I do want to remind you guys, anytime you have a cone, you're gonna probably, I'm gonna say about 95% of the time, you're probably gonna have to use similar triangles. Okay, so I'm already gonna prep for it. Okay, I'm gonna do this R and H. Okay, now why do I know I have to do that? Well, because look at my formula. Okay, volume equals to 1/3 pi r squared h. The issue I have with that formula, if I'm going to take a derivative of it, is I'm going to have to take a derivative of v, which is going to give me dV/dt, and that's okay because I know dV/dt is -2. Okay, then I got to take a derivative of h, which is fine because I got to find dH/dt. So derivative of h will give me dH/dt. And then I got to do a derivative of r, and the derivative of that would be dr/dt, but guess what? They didn't tell me the rate of change of the radius, and I can't just make it up. Okay? So that means that I have something in this equation that I won't know how to do. So let's get rid of the part I don't know how to do, the dr/dt. Well, how do I get rid of the dr/dt? Well, let's just not take a derivative of r. So how do I get rid of r? Well, that's where similar triangles comes into play. All right, I know that 1.5 on the radius over 4 for the height will be equal to radius over height. Okay, that's just similar triangles. Okay, so that means if I solve for r, I can replace it with h. So r is equal to 1.5 over 4h. Now, the way I did this when I did it in class last time is I rewrote everything, right? Because I didn't want to do a 1.5. So I know 1.5 is 3 halves, and 3 halves divided by 4 is 3/8. Okay, so this is your r value. Okay, it's 3/8 h. Okay. So again, I just rewrote 1.5 as 3 over 2, and then 3 over 2 divided by 4, that's 3 over 8. All right. So now that I know that I can replace r with an h variable, I'm happy with that because, again, I want h's in the problem because I need a dH/dt. All right. So v is equal to 1/3 pi. R is 3/8 h squared, and give me a second. Sorry about that, I just got stuck. That's 3/8 h squared times h, okay? So let's go ahead and, oops, give me a second. I just realized I forgot to display this up there. All right. So I plugged in the R value right here, okay? So instead of R squared, I put 3/8 H, and then I'm going to square it. So now I'm going to go ahead and multiply this out. So it's 1/3 pi 9/64 H squared times H. So that's 1/3 times 9/64 is 3 pi over 64 H cubed. Okay, because the 3 and the 9 will reduce. And then H squared times H is H cubed. Now I only have V and H. That's perfect. I'm going to take my derivative of everything. So dV dt is equal to 3 pi over 64 times 3H squared dH dt. All right, now I got to solve for dH dt. So let me do a real quick cleanup here. dV dt is equal to 9 pi over 64 H squared dH dt. And I'm going to divide everything by 9 pi over 64 H squared, okay? So it's going to look really messy, but just bear with me. dV dt over 9 pi over 64 H squared is dH dt. I don't like to plug in numbers here and there. I want to solve it all for one thing, and then I'll plug everything in when I'm ready. So now I'm ready. I'm going to get dH dt and plug in H equal to 3. That's what they wanted me to do, okay? So dH dt, when H is 3, is equal to, well, dV dt is -2 over 9 pi over 64, and this is going to be 3 squared. So if I simplify the right side, that comes out to, that's 3 squared is 9, that's 81 pi, so it's -128 over 81 pi. And this is height, so it's inches per minute. This is my answer. The key is this, the proportion that we do. Okay, that's similar triangles. That's the key. And I'm telling you, anytime you're given a cone problem, unless something is constant, you're going to probably have to use this similar triangles idea to substitute either for R or for H, one or the other, depending on what they want. If they wanted to know dr dt, then I would have substituted the H out and put R's in there. That way I'd have R values in it. It just depends on what they ask me for. But that would be number one.
What is from 364 to 5, how does it become 3H squared? Wasn't it 3H cubed?
You're saying this part right here?
Yeah.
So it's because that was my derivative. I took a derivative of H cubed. Yeah, I'm just looking. I'm like, yeah, how did that happen? But I saw dH dt. So yeah, I took a derivative of H cubed, so that's 3H squared. Well, I have to take a derivative of everything implicitly. I want to take the derivative of this function. I got to do left and right side. I can't just do left. So I'm going to take the derivative of the whole thing implicitly. So when you do it implicitly, since everything is with respect to time, then when you take a derivative with respect to a volume with respect to time, it's dV dt. And then when you take a derivative of H with respect to time, it's dH dt. And remember, that's what we're looking for, right? dH dt. So we want that value.
Why is the radius 1.5?
Because they say that the top is 3 inches across the top. So they gave me the diameter of it. So it'd be half of it, yeah.
What do you mean by implicit?
Implicit differentiation means that you don't have to solve for y or for x or for t or whatever. You just do it. So like, for example, if I gave you this and I said, take a derivative of that with respect to time, then you would have to solve so that there's t values on one side or the other. But notice, do you see any t values? No. So you have to do it implicitly. So in other words, the derivative, if I'm doing this with respect to t, okay? Respect to t. So d dt of this would be 2x dx dt plus 2y dy dt equals to 2s ds dt. That's with respect to time, okay? Respect to t. Now, if I would have said, let's do this with respect to y, the same function with respect to y, this would be 2x dx dy plus 2y. Not dy dy though, because that's the right letter. Equals 2s ds dy. That's with respect to y. If I did it with respect to x, it'd look different. Right? So that's called implicit differentiation. In other words, I don't want to solve for one letter, I'm just going to do it. And that's important for related rates. Like, you need to be able to do that. Because you never are really solving for one thing or the other. You're just kind of doing it and then rearranging as you go. Because I could have, if I wanted to, I could have solved this function right here. I could have solved this for h if I wanted to, and then taken my derivative from there. But sometimes it's not easy to do. So this one wouldn't have been that bad. It would just be a cubed root of something. So, but I say why? Why waste my time? Just do derivatives. Any other question on this one? Concerns? All right, question number 2. So air is being pumped into a spherical balloon. So here's my spherical balloon. At the rate of 7 cubic centimeters per second. So cubic centimeters is volume, so that's dV dt. They said it's being pumped into, so 7 cubic centimeters per second. Okay, so that's a positive. What is the rate of change of the radius, dr dt? Rate of change of the radius at the instant the volume equals 36 pi. So when volume equals 36 pi, that's what I need to know, dr dt. And then they tell you the volume of the sphere is 4/3 pi r cubed. So we're going to start off with volume. The reason why I'm going to do that is because I know dV dt, so I know I'm going to have to do that at some point, take a derivative of it. And I know I'm going to have to take a derivative of r because they want dr dt, right? So let me go ahead and take a derivative implicitly with respect to time. Okay, so derivative of v dv dt. 4/3 pi, just kind of ignore it. It's a constant, just leave it there. The derivative of r cubed, 3r squared, dr dt. Okay, so there's my derivative for that function. Now, they want me to find dr dt. Okay, so let me fix this up a little bit. dv dt is equal to 4 pi r squared dr dt. And if I solve for dr dt, I get dv dt divided by 4 pi r squared. That's my derivative solved for r, or solved for dr dt. Now, they told me, figure out this rate, dr dt, when volume is 36 pi. So dr dt, when volume is 36 pi, that's equal to, they told me dv dt was 7 over 4 pi, but then I get into this little problem here. I don't know what r is. They never told me, but they did tell me something. They said volume is 36 pi. I know the volume formula, so volume equals to 4/3 pi r cubed and they said volume is 36 pi. So if I know that volume is 36 pi, I can figure out the radius, okay, just by solving for r. So if I multiply 3/4 on both sides to get rid of the fraction, that comes out to 27 pi equals to pi r cubed, and cancel out the pi's. So the cubed root of 27 will be r, which is 3. So I can put a 3 in my formula. That's the radius of the sphere with the volume of 36 pi. It's 3, centimeters? So 3 centimeters. So now I'm just going to multiply this out. 7 over 3 squared is 9 times 4 is 36 pi. This is dr dt, so radius is one-dimensional, so centimeters per second. So there's that. Questions on this one? I mean, this one's pretty straightforward. Just the very end requires you to say, where the heck am I going to find my radius? I don't know where it is. They didn't say it. You're going to read it again. You're like, it's not there. So hopefully the light bulb goes off and you're like, oh, they told me a volume. Let me plug that into a volume formula and figure out R. Right? I can figure out my radius that way. You had a question? That's in the problem. It says, what is the rate of change of the radius at the instant the volume equals 36 pi? So they actually, I put it right here. They told that to me. Volume is 36 pi. So at that moment, I can figure out my radius by using the formula for volume.
How did you get 4 pi r squared?
4 pi, oh, this will cancel here. I mean, if you don't want to do cancellation, just multiply 4 times 3, that's 12, divided by 3 is 4, right? You can do it that way too, but just cancellation is fine. Any other questions on this one? Make sure you guys know how to do this, because if I remember correctly, there is a sphere problem. Sphere problems are easy, but there's always one little hiccup, right? The hiccup is that maybe they don't give you the radius. You might have to figure that out yourself. Okay? It's not hard to do. It's just that right side. Just use like geometry. That's all we're using, right? Plugging it into a formula, solving for R. Yeah, it's just a little hiccup that you may not expect to have to do. There's always something in every problem that it's unexpected and you got to figure out like, okay, how do I find that, right? So, anything else on this one? All right. So, question number 3. Remember, the rest of them are recorded for you guys. So if you need to see 4, 5, 6, 7, 8, and 9, you guys definitely look it up. Don't just go to my video section. So Art was having an issue trying to find my video. If you just go to where it says videos, there's like almost 300 videos you're going to have to go through. Okay? Go to where it says playlists, and under playlist find Calculus AB. And then in there, go to section 2.6, and it should be somewhere around there. Who was it? Roddy? Huh. All right. Now here we go. Question number 3. A kite 100 feet above the ground is being blown away from a person holding its string in a direction parallel to the ground at the rate of 10 cubic feet per second. So, all right, here we go. Just so that we don't have to, so that we can ignore the height difference. Okay, I'm going to make them lay down. All right, they're going to be laying down. So here's your kite. I'll put a little bow on it. There you go. Okay, let me reread this. A kite 100 feet above the ground. okay, 100 feet above the ground, is being blown away from a person holding its string. So it's being blown away from a person that's holding the string, and it's being blown away in a direction parallel to the ground. So the kite is being blown away that way. So if I call this x, then this is dx dt. Okay? Now I want you guys to understand, they said that it's being blown away in a direction parallel. So does that mean it's going to go up and down? No, it's being blown away somehow miraculously. It's never going to move straight across. Okay? So that's what they mean. Like it's constantly being blown away this way. So is the height constant? Is the 100 feet going to stay 100 feet according to this problem? Yes. So can I plug that into my equation immediately? Yes. Okay? Because the height is not moving. They said it's being blown away in a parallel direction. So it's good to remember this. Anyway, it was being blown away at a rate of 10 feet per second. So 10 feet per second. Okay? At what rate must the string be let out? So let's call this S. When the length of the string already is at 200 feet. So ds dt, the rate at that the string is being let out when S is 200. That's what they want to know. So I see a triangle here, right? Did they mention anything about area for this? Like, are they saying the area changing or decreasing? No, right? So that means I can't use area equal to half base times height. That's not going to help me. So this is a triangle, so let's try the Pythagorean theorem. So I would use x squared plus y squared equals s squared, but I know that y is not changing. So x squared plus 100 squared equals to s squared. Okay? Now, I'm not going to work out what 100 squared is. It's going to be a waste of my time because when I take a derivative of 100 squared, what is it? It's zero. It's a number, right? It could be a million, a billion, a trillion. I don't care. It's a number. So the derivative of a number is zero. So this is going to be 2x dx dt plus 0 equals 2s ds dt. Again, the 100 squared, that's just basically 100 times 100, right? It's 10,000. The derivative of 10,000 is 0. It's a number, okay? I'm going to divide everything by 2. In other words, canceling it out. Okay, so I get x dx dt equal to s ds dt. Remember, my whole point is to get ds dt. On the very top right, you can see it, ds dt when s is 200. So let me solve for ds dt. I'm going to divide by s. So ds dt is equal to x over s ds dt. I'm sorry, dx dt. Are we okay with this so far? So they said figure out what ds dt is when s is 200. So s is 200. I'll put that right there. What's dx dt? They said it's 10 feet per second. And x, well, that's a good question, right? What is my x value? So I know this is 100. I know that's 200. So that means this is the square root of 200 squared minus 100 squared. Right? Just using the Pythagorean theorem. Okay? And also not having a calculator, so that's what I'm going to basically leave it at. Okay? So that's my x value. 200 squared minus 100 squared. Now this 10 will remove one of these, so that's what is that? 40,000, right? 40,000 minus 10,000, that's 30,000 over 20. And I don't know what that is, but S is in feet and time is in seconds. So it's whatever that is. I think I did that right. Pretty sure I did that. Are we okay with that one? Uh-huh. The Pythagorean theorem part? Well, this is just x, right? So it's just x squared plus 100 squared equals 200 squared. So it's just x squared equals to 200 squared minus 100 squared. Again, I'm not doing it, I'm being lazy, right? But that's 40,000 minus 10,000, so it's 30,000. So x squared equals to 30,000. So x would be plus or minus the square root of 30,000, but distance can't be negative, so that's how you get that. Any other questions? Uh-huh. You probably did. I'm not that smart. I mean, I can start breaking it down, right? That's 300 times, that's 100 times 100 times 3, so that's 10 times 10, so that's 100 radical 3 over 20, so 10 rad 3 over 2, which would be 5 rad 3.
Yeah, okay, that's right.
And now you challenge me, see, now I got to show off. So that would be your answer, 5 radical 3 feet per second. Now, yes, I would expect you guys to do it because you're probably just going to punch it into a calculator maybe and just like voila, right? If you're going to do it in your head, then good for you. I had to do all this stuff. My college career, no calculators. Everything I did, every calculation, from calculus. Actually, I started in trig. So actually, I started in college algebra. So everything I did in college algebra to trigonometry to calculus 1, 2, 3, and 4 to advanced calculus to discrete mathematics, modern geometry, elementary algebra, everything I did. No calculators. Everything had to be done in your head. So that's why us old people, or what you guys call us old heads maybe, is that still a thing? You guys still call old people old heads? I know boomers is out of fashion now, right? Maybe people still say. But us old people, we do everything here because we had to. They didn't let us. Plus the cool calculators you guys have that right now cost $140, those were $500 calculators back then. And $500 back then was the equivalent of like close to $1,000 now. So I'd rather buy a Nintendo than a graphing calculator. Okay. So that's what I did. I bought myself Nintendos and Sega Genesis, stuff like that. So yeah, we just did stuff in our head. So yeah, when you see us working stuff out, it's not because we're that good. It's because we had to. We had no choice. We had to.